My name is Schelgo. This is our OS project, namely Schelgo. We have implemented four types of algorithm, that is page replacement, page scheduling, CPU scheduling, concurrency and deadlock. First of all, in page replacement, we inserted the details of the page replacement for which kind of use the page replacement is there. In page replacement, we implemented two algorithm examples, that is MRU, that will explain later. In that, after that, we inserted this scheduling. We also inserted the information about this scheduling. In this scheduling, we also implemented two examples, that is scan and scan. In that, we inserted details about this scheduling, what factors are needed in this scheduling like seek time, rotational latency, transfer time, disk access time, like that. And we have two algorithms, that is scan and scan, and there is information about that. After that, we implemented CPU scheduling. There is information given about the CPU scheduling. In CPU scheduling, we inserted an example, that is round robin. We also given information about CPU scheduling, or which factors are needed to proceed CPU scheduling. That is arrival time, burst time, finish time, how many processes are there, how many users are there, or average turnaround time, average waiting time, etc. We also give information about round robin. After that, we implemented last one is concurrency and deadlock. The concurrency and deadlock have one algorithm, that is Banker's algorithm.
Hello everyone, I am Swarat and in this video I am going to explain about page replacement algorithm. So a page replacement is referred to a scenario in which a page from the main memory should be replaced by a page from secondary memory. So if we take an example, let's see that there are 3 frames and for number of pages let's take 5. Now if we input these particular values in the pages, let's take 0, 1, 2, 1 and 2. Now if we submit this, so as we have taken 3 frames, so for the first 3 frames there will be no pages in the secondary memory, so it will get page fault, means there will be no hit. And for the fourth, as one is already in the secondary memory, it will give a page hit because it's already there, and for the second also it's in the secondary memory, so it will also give a hit. And if we take the total number of hits, there will be 2, and for the number of page faults there will be 3, so the hit ratio will be 2 by 5. Thank you. So now for disk scheduling algorithm, so there are two algorithms that we have implemented, scan and there's scan. So first for scan, if we take input values, let's take number of requests be 3, total number of tracks 3, and for head position we take it 0. We choose the direction left, and the tracks, let's take 1, 2 and 3. Now if we run this algorithm, oh sorry, it's -1. So we get a chart here, and so the total seek time here is 5 millisecond, and the average seek time is 1 millisecond. And we also have the options to download the image, and as well as we can form a PDF of this thing. So for PDF it's, yeah, so the total number, as you can see that what we have inputted the values. So now the only difference between scan and the scan algorithm is that in scan we can take both the direction forwards and backward, while in scan it can only move in one direction. So now our third project is round robin. So round robin is a scheduling algorithm which is kind of preemptive. It is a scheduling algorithm where each process is assigned a fixed time slot. So here as you can see in the website we have information about round robin on this part and about algorithm on right side. So now if we take a practical example, let's take burst time for processes be, let's the burst time for processes be 2, 3, 5, 6, and for let time quantum be 2. Time quantum is the minimum time that the CPU takes to execute a process. So as you can see here, we have got a table where there is a turn around time and waiting time. So the average around time is 10.25 and while the average waiting time is 6.25. And here is the graph for CPU queue. So in round robin scheduling, the time quantum is fixed and processes are scheduled such that no processes use CPU time more than one time quantum in one go. So if the time quantum is too small, unnecessary frequent contexts which occur. So in concurrency and deadlock, we have implemented Banker's algorithm. Well, Banker's algorithm is an operating system which is used to avoid deadlock and for resource allocation. While Banker's algorithm in operating system is used to avoid deadlock and for resource allocation. So when a new process is created in a computer system, the process must provide all types of information to the operating system like upcoming processes, request for the resources, counting them and delays. Based on this criteria, the operating system decides which process sequence should be executed or waited so that no deadlock occurs in a system. Now if we take an example, as we have here a button where it will automatically input the values. So as you can see the values are randomly generated. Now if we run this algorithm, this page is it shows that it is safe to run. Now as you can see the page has turned green, which means that the deadlock situation was not created. Now as you can see, now let's change the resources. If I decrease it by 2, now if I decrease it by 3, let's if I take it 2, and now if I try to run this algorithm, then it shows that it won't be able to uh, allocate the resources to the process. Why? Because the other processes are already having those process resources, and as you can see that the page has turned red and deadlock occurred.